How do we do it before?
Um,
Intro and then our names. I'm blank, you're blank. Brase makes.
Hey everybody, and welcome back to
Brase Makes with James Collins. This is Brase Makes. I'm Andrew,
I'm James.
and we're gonna make some more models today.
Heck yeah.
Do we want to card out some of the original models?
Let's bring them in.
So you start off with our first episode. We have our 1D models, which are, we got a front view, side view, and then we did a simple operation of creating a slot. So we get kind of a, not quite 3D, but more of a 2.5D model. And so this told us a lot about the scale, and it was pretty quick. It only took us maybe 10, 15 minutes
Yeah.
or so. And then we've got our, as we were figuring out our mechanisms, we kind of used some off-the-shelf, well, out of the recycling bin components. We used some bottles, some takeout containers, and started to figure out more of the mechanism. We got spinning blades, and so from that, this I think told us a little bit more about the form, but the scale's still off.
Yeah.
And so with this model, we've locked in the scale with these, and we've got a better idea with the form on these models, and so now we're sort of building a looks like that is the right size.
I think one thing that might be worth mentioning is one of the reasons that we wanted to do this model making approach is because there are a lot of small industrial design studios right now that are utilizing this approach.
Mm-hmm.
And I think that a lot of people are curious about it.
Mm-hmm.
They're curious about how to go about generating it, and they're curious about how it all comes together.
Right, so
Where do I sign?
So a little bit of background. So I took your original CAD model, and for this sort of flattening process, we needed to remove all of the compound curves. So paper can fold in one direction or another, but to try to do them both at the same time, you get a lot of weirdness. Whenever you need to make it real, you have to define the scale.
Right.
You have to break it up into a surface that actually exists in space.
Right. It's like making an STL. Like you can,
Yes.
that's like when you really can see how that gets interpreted into a physical thing.
Right. Do you want to, let's do two hemispheres together. I think that's sort of that's the big test, because the sphere is a compound curve all around, right?
It also seems like something that's going to be pretty immediately satisfying.
Mm-hmm.
I'm hoping.
So let's see. I'm going to separate. This is sort of the base and the back, and I think as I fold these, they'll start to make a little bit more sense.
Mm-hmm.
So I'm going to cut and give myself a little bit of a, maybe like an 1/8 inch all the way around, and then you can, as you start to kind of like set things together, you can decide where these tabs go. So this is going to become the, if I fold along these, this will start to become the dome.
Okay. Yeah.
And then this guy kind of fits.
In the center there.
Yeah. And they all kind of like fold in on each other. I wanted to do the best I could with tools that anyone should have access to.
Mm-hmm.
So, I didn't want to assume that everyone's using SolidWorks or has, a copy of Rhino or something like that.
Right.
So I was using Fusion 360 for the modification of your model.
Yeah.
And then they have a tool called Slicer that's integrated. And so that actually gives you a lot of options in terms of like taking this form and slicing it up into whatever thickness material, and just stacking all your pieces together, kind of like you would do with 3D printing.
Yeah.
Or if you're doing a kind of a slotted together model like this, it definitely has its limits, but if you're just starting out with it, it's like a good thing to play with. And then it also has this sort of like unwrapping tool.
Cool.
But I found some limitations with that, and we'll get into that later.
Right. And Fusion, for those of you who don't know, is a free program if you're a student or if you're just like a tinkerer.
Student, hobbyist, they have a free version that's pretty easy to access.
So you are cutting out triangles at every one of these folding points.
As this outline is where the actual edge is.
Yeah.
and those you're going to want to fold over. So
Right.
if you try to fold, if you're trying to do, again, this becomes a compound fold, and that's where you start to get these like little crinkles and stuff like
Right.
that. While I did use Slicer, I did try out a trial of this software called Papercraft, which is pretty popular for explicitly like Papercraft type stuff.
Yeah.
You have a lot more control over the tab design, how like where your seams are in your mesh. I think what I'm going to do here is I want this to be sort of like the piece on top that kind of glues onto the surface.
I see.
So these tabs are going to be hidden underneath this.
Yeah.
So I'm actually going to trim this to the line and remove this excess material.
Okay. Now, when you use this program, you said that it gives you, does it give you a preview of what your model will look like when it's assembled in this way?
Yeah, well, it gives you what it thinks it'll look like.
Okay.
You still have to go into it with a pretty good idea of how you would approach the problem.
Right.
And that's something I've found with actually a lot of these, like the research I did in these different ways of trying to achieve what we're doing right here. Nothing's automatic.
Yeah.
So from having to you have to engineer your model for this process.
Right.
And you have to simplify certain things. There's like not really a good way around that outside of like manually going in and just like removing all your fillets and radiuses and
Right.
things like that. You know, even with Rhino, what I've found is that it does have a nice like unwrap tool that just is like very straightforward. Like you hit a button and it unwraps it, but you don't have a lot of control over how it unwraps it. And so if you do anything more complicated than kind of what we're doing here, it can really quickly get out of control where you have some weird, impossibly long, unfurly thing that you wouldn't really be able to necessarily assemble.
So how are you gluing this?
So here's a problem I have not solved yet. When you're trying to make an enclosed shape, how do you get that last tab?
Oh, yeah.
I don't have a good solution for that yet.
Okay, so we have solved Andrew's plight. Yes? Does this solve? I mean, it's not the prettiest thing.
It's a solution.
It's a solution.
We've got now two hemispheres, so we have our design. It's split into two halves. So one side, two sides.
Three sides a lady.
Okay, so it's taken about 45 plus minutes to get two parts done between two people.
Yeah.
So that's 1.5 man-hours
Yes.
for these two parts.
30 times 45. We're about to find out.
That's
1,350
minutes.
minutes.
How many hours?
Divided by 60. 22.5 hours. I mean, let's be fair. Some of these are not as complex as the others. So I could imagine this if you are an experienced paper
If you know what you're doing.
maker. Maybe it takes you a day. For the lay person,
Longer.
yeah.
Okay, so I'll show you what I got done.
Okay. I'm so excited about this, actually. Apparently, I forced Andrew to work on a model for 3 days straight. Is that true, Andrew?
No, I didn't finish it.
Oh, no.
I got through one page, so I got through a single page
Yeah.
with the hemispheres, which clearly didn't survive, I guess.
Yeah.
The last day or two somehow. And I started to work on the blades, and I gave up after the second blade. It took me about 2 hours to get to this point, 2.5 maybe, before I was like, I honestly just not interested in finishing
Before you said, I hate James Connors, that son of a... Do you think that this has to do with the delicacy of this particular model that the parts are so small?
Yes. So there are a few. Here are all the things I think are wrong. Like this answered a lot of questions. The solution to time ratio,
Yeah.
I feel like, is much better on this.
Right.
I feel like even if we built this in a pristine manner,
What would it get us?
What would it get us over that?
Right.
Given the time sink that this could be.
Yeah.
So that took us, if we were focused on it, like what was like an hour and a half, 2 hours maybe.
Yeah.
This could take like even if it was just a day,
Yeah.
a work day, would it be more valuable to do this over that? Is the question.
I do think that is great about the model making process is sort of the taking of time and sort of like meditating about what it is that you're doing, because I think it can unlock things about your design that need improvement, need changing. So I feel like, we did get a lot of that out of this one, and maybe this one is it's just a little too much time to be valuable in that way.
Yeah, I found that the examples of papercraft that I've seen and the examples of prototyping with paper that I've seen are usually human scaled objects. So it's a lot of like furniture.
Right.
Or if you're creating like cosplay, like costume armor and stuff like that.
Right.
This dome, if it were, this big and out of, or something stiffer, would probably be a lot easier to put together.
Right.
What else? Oh, I wanted an anecdote. I was speaking with my friend Ilya, who he actually does a lot of model making, but for film and commercial. He's coming from more of an animation background, and he's actually done several commercials where the whole aesthetic is this sort of papercraft folded thing. And what he had told me is actually, if you're just doing a one-off, if you're not trying to like make multiples of something, a lot of it's just by hand, and you're just sort of like through experience, you kind of sketch something out and then you just start folding paper.
Right.
And if you're doing like a forest of trees, then you might, engineer one tree and make a bunch of them, and actually go through the effort of like modeling it in 3D and then breaking it back down to make it 2D to then make it 3D again.
Gotcha.
And then another thing that I thought was interesting are things like spheres are sort of one of the more difficult forms to do in paper, because a sphere, again, it's one big compound curve. And what they actually did in this particular shoot, they had like a ball pit. And so they made one out of paper.
Yeah.
And they actually made a mold and cast them.
Oh, interesting.
Because then they wanted the texture, they wanted it to look like paper.
Yeah.
And so they made one out of the real material, but to get that texture, they actually molded and cast it.
Right.
And that's where, again, like I'm like, all right, at some point you should move into a new material, a new technique.
Yeah.
If what you're wanting is a higher fidelity finish.
I feel like this is actually an entire lesson in why industrial design itself makes sense when you're getting to a certain scale. It's like at some point, crafting things just takes far too much time, far too much effort, would cost an exorbitant amount because of how many man hours it takes. And so by producing things industrially, then you're able to reduce the cost, reduce the time, free up labor.
Mm-hmm. Yeah, I think the industrial part of industrial design usually suggests mass manufacture.
Yeah.
Right? The scale is always implied that you're going to make, 1,000 of these, 2,000, a million.
Right.
I actually almost forgot. I do have one other model that I did in a slightly different technique, and actually completed it and came to the same conclusion. So I mentioned that there is another way to slice this, so there's basically a more complicated version of this. Before I show you the model, I'll show you the plan.
Oh, man.
So
Teasing.
these are the slices.
Okay.
Here, let's make a little bit more room.
Yeah.
So these are the slices. This is assuming that I'm using cardboard.
Okay.
So this, in the software, you can put in the thickness of the material.
Gotcha.
So I chose a fixed, source of cardboard, input that information, and then it generated these slices assuming that thickness. So the first thing I did was take this and spray mount it to the cardboard.
Right.
And then cut these shapes out.
Yeah.
Here's the result.
Woo! Woo! Oh my gosh. Wait, does this spin?
I just kind of loosely tucked it in there. So
That is so cool though.
so that's sort of the high resolution version of this.
This look itself is so impactful and interesting, but it's like you could create that almost like
This could be a skeleton that you then, like an airplane wing,
Yeah.
where you have the cross sections and then you kind of stretch something over it.
Yeah, and you could create that solidified form using some of this. But this is so cool. How long did this take?
3 hours.
Okay. Oh, that's awesome.
I think as a whole, it looks a little better as like a complete piece. If you start to get into the details, it's pretty hacky.
Right.
You know, it's assuming like if you're making a cube and everything kind of like slots together this way, like this,
Yeah.
that's pretty simple. But then if you have something that is radial,
Right.
then that creates some new challenges. So like with the sphere, this is sort of a radial chop.
Yeah.
Maybe hopefully see this from the top. So you have these layers kind of building up this way, and then you have these kind of crossing along the center axis.
Yeah.
On the bottom, I actually chopped it up into 3 components because that radial design wouldn't really work with these because we still want these to be parallel.
Right.
The PCFs, we want to remain parallel.
Yeah.
And so I actually chopped this, knowing that, chopped this into thirds, and then did this sort of like horizontal slotting to keep things in the plane that I wanted to do.
Yeah. Realistically, a day's worth of work.
Yeah. Yeah.
And I mean, I don't know. What do you think that would be worth it to get that over?
I mean, a
right.
solid day, like 2 hours.
Right.
I feel like this answers more questions than this.
Yeah.
Like, what does this do that this doesn't?
I guess the only thing that it does is it retains the proportions because this
It does change the proportions,
because,
like squatter and
right.
stuff like that, because we're using the found objects.
But I mean, this tells you a lot about your proportions. I mean, I could almost see if you slotted in like
More
two
of a
more
radial-
sections, how that actually could tell you a lot about your proportions. So yeah, I mean, it does still seem that like these two are much more worth the time and effort.
I think it really depends on what your goals are.
Yeah.
And that's what you should be asking yourself before you build any model. It's like,
Right.
what do I want to learn from this? And then decide with, what your constraints are around that.
Right.
If you're a designer, a product designer, and you want to like really rapidly iterate and explore the form and like start figuring out some of the engineering problems, then, your time is probably better spent at more of a course level and then jumping off of that into the next iteration than spending, a day or two, polishing a turd.
Fair enough. Yeah. No, absolutely. I am curious where do we go from here?
I think that I think it'd be interesting to take some of those engineering issues that got brought up and actually start thinking about how this thing might go together.
Yeah.
And so maybe it's time to address 3D printing.
Sounds good.
Cool. Well,
yeah.
all right, there we go. Until next time.
Yeah.
All right.
I'm James Connors.
I'm Andrew Brase.
And this is Brase Makes.
Okay.
Cool.
I think that'll work.
Yeah. No, I think that's great. I'm sorry that you went through such pain.
No. I think it was important.